Hi everyone. Hi Srini. Are you able to hear me clearly and see my screen clearly? All right. All right. Now, good. Good. All right. Shall we start now? All right. So yesterday we talked about quite interesting things. Some of those were how to interact with various systems. Okay. So the most important diagram that we did yesterday was this. So using data frame as a concept, data frame as is an abstraction on the top of RDD. So you load your unstructured data into RDD, and from RDD you create a data frame. And on data frame, using data frame, you can do a lot of magic. You can register data frame as a table, and then you can use Spark context Spark.sql. Okay, and to so data frame is nothing but a table structure having named columns, and we can query this data frame, and this tabular structure can be queried in an R way, in the way we call R, or we can use it with SQL by registering it as a table. Now, interesting part is a data frame can be created out of RDD. Data frame can be directly created from JSON, Hive, CSV, XML, and so on. Those who are wondering how to create using Avro or XML, somebody had asked me yesterday that these two topics I would like to take today. Okay. I'm not sure. Okay, I can see Mohit is here. All right. So yesterday, if you remember that we talked about how to load XML and Avro, right? So XML is this kind of data like an HTML. HTML is basically a form of XML. Here, so whenever we want to categorize something, we create a tag, right? This is a tag. Here, category tag is a catalog. Then inside this folder, or you can inside this taxonomy, or inside this tag, there is another tag called book. Inside the book there are another tag, and so on. So we can we can store our information in this kind of hierarchical way, right? That's XML. All right, this way you can generally store complex data, but as you can see that to represent a small thing, we say first catalog, then close it. In the similar way, we first say book and then close it, and so on, right? That way it could be a little, so it can be a very time consuming exercise. I mean, a space consuming format. It is an space consuming format. So this is XML. So is everybody aware of XML now? Yes. George, Kar, Manu, Mohit, Narendra, Ravi, Shamit, and Srini. Indentation is not important. Okay. Indentation is important in other formats. Say, for example, there are two things. One is called YAML. Okay. Indentation is important in YAML and in Python code. Okay. Indentation means leaving space to the left-hand side. In case of XML, indentation is not important. Very good question. All right, this is something I always forget to tell. All right, So this is how XML looks like. So we have one book, we have another book, and we have more books in this XML. And there is and the whole thing is covered in something called catalog. You can see. So catalog has first book, second book, and so on. All right. You can take a look at this data by, let's say, by saying Hadoop fscat, and here, let me log into my console. So I say SSH. Okay. It's the same thing as web console that you use. I'm saying, show me this data. So you can see that here, it's not big data, but it has some 20, 30 books. Okay. So first book is having this author, the name of the book is, title of the book is this, and so on, right? And similar is the second book and third book. All right. So this is our XML. And if you want to, let's say, load this into a data frame, and then we want to query it, it's actually pretty simple. Okay. So what we can do is we can do this way. We can say, okay, we are saying here, important part is first we will launch Spark Shell. Okay. So this is a format that we are going to tackle. And we are going to use this particular library. Okay. So those who are interested in this, I'm copy pasting it for them. So because it's not there in slides yet, because we have recently updated it. So now we are going to launch this Spark cell. All right. And how do you launch? By running this. Here, there's a very important aspect. That is something we have mentioned once, but we did not go into details. So what you see here is package. Okay. Now, what is a package? Package is a library contributed by somebody, and this kind of package, like Spark XML, is a public package. It's not really uh, part of the Spark code. So you have to first download and then use it. The good part about this package reference is that when you launch shell this way, it will download Spark XML, okay, and start using that. Okay, it does the work like SBT package. In SBT package, basically downloaded this package and queues it. So whatever is found in the config file, it downloads. Similarly, Spark Shell also, in the newer versions, it basically downloads the packages passed on the argument. Okay, I'll show you. For me, since it has been there, it'll be very quick. Okay. So I'm going to make it looks like other people are also using it. Okay, so now that's it. So we have been able to start Spark version 2.0.1 with one extra library, which is downloaded from the internet, called Spark XML, right? Now, the next statement is we are saying spark.read.format XML, or if that doesn't work in older versions, you can try this. Okay, the absolute name. So here we are saying, so this is our format, and we are saying that the row tag is book, meaning when it will convert each thing into a record, from which point to which point is a row. Okay, from which point to which point is a row. So that's why here this is the tag, this is the name of the tag. So we are saying each of this tag from here to here will become our row, which means all the attribute under it will be the column values for each of these rows. Okay, now once we are done with it, we can simply start it with You can see that. So we are defining the format XML. We are telling it that this is book tag is our row. Okay, and then we are loading this data. This data contains the details as I showed you. Now, once it is done, it has done mapping it, then we can see the details by saying df.show. When we say df.show, then actual work happens and it is actually brings data. Now you can see that it has basically every record has become the column here. Okay, so I will go back here, go up. Or let me just go to the slides, that will make it clear. Okay, so here every record is a book. Okay, every record is a book having uh, having the author, description, genre, price, publish date, and so on. Okay, and title. Did it make sense to you? All right. Okay. Now somebody was asking a question from Mohsin. Nested nodes like addresses became part of the same table. Very good question. Very good question. Let's take a look. Okay. So generally, when you have nested things, they become array inside each record. Okay. If you have a list of values or object, they become a complex object here. Good. Very good question. All right. Remember yesterday when we were loading some data and one of the records like subscription or something was an array of values, so that that values of the shell became the entire array was a value. Okay, good, good, good. Any questions at this point? All right. Now is we're talking about Avro. Okay. So Avro is a data format which was primarily used in Apache Hadoop. Okay. It provided, it can, I mean, it was primarily for the use of Apache Hadoop, where it can provide both serialization format for persisting data, as well as wire format for communication. Okay, so it's kind of a competitor of Thrift and protocol buffers. Okay, just that instead of coming up with the own format for specifying configuration, it uses JSON. Okay, so Avro is another format which is used in case of Hadoop while saving and retrieving data. Okay, and it's while it saves the data, it converts the data into binary format, which is very compact, and it does not require a third-party code generation step. Okay, it basically does not have the code generation. You basically specify the values of header, values of name of the attributes, data type, and everything in the JSON format. Okay, similar to XML, loading JSON data is very straightforward. All you have to do is use Spark Shell this way. Okay, basically downloading this particular library from the internet by passing it on the name of the library on the packages, and then calling the spark.read format with this and load the actual data. That's pretty much. Okay, so this way you can load Avro data and write to Avro data. Similarly, you can say spark.write.format this and write. Okay, so yes, RS, we have talked about how to store and save the two formats, XML and Avro. Okay, all right, we have talked about these parts. Okay, Beeline is kind of um, newer version of Hive console. So you can use Beeline for connecting to console. All right. Now using Beeline, you can talk to uh, Spark and move on. All right. Now, should we move to Spark R? All right. So just like we have a programming language called Java, Python, Spark, Scala. So just like the way we have programming languages like Python and Scala, there was a programming language called R. R is a very old programming language and basically is uh, is very rich when it comes to the library. If you take a look at, that's the most fascinating feature of R, because it is open source and widely adopted and is pretty old, and therefore it is basically having the greatest number of libraries on the planet amongst all the languages. Okay, and specifically, most of these libraries are around data, as in are around data churning. Okay, data science, data churning, machine learning, and you will find like some libraries for sociological behavior, biological behavior. You will find these amazing set of libraries, and it seems that most of the planet, I mean, most of the people who are into data science background, who are from data science background, they generally use R. Okay, so the way Spark made itself run by using Scala. Scala was a nice programming language, giving the interactive console. So Spark came along and said that, okay, we will make Spark available inside Scala. Okay, and as a matter of fact, most of the Spark's development has happened in Scala. Okay, now on the same time, it came up with saying that we will make Spark available in Java, and it made available in Python. Now, good news for Spark is, or any new libraries for that matter, okay, it's not only Spark, by the way. The newer libraries in the today's world, whatever libraries are coming, they are trying to make themselves available inside all programming language. Let's take a case of TensorFlow. TensorFlow is new machine learning library from Google, and that library is actually pretty powerful and popular, okay, for deep learning and machine learning and all advanced computing. Now they also took the same step. They made TensorFlow available inside Python console, as in Python, as a Python library. Similarly, they also made TensorFlow, okay, TensorFlow. I'm giving another example that has come with a same behavior as Spark. So they made TensorFlow available as a library in R as well as Python. Okay, so that's the advantage. That's the big advantage of this era where you don't have to create a new programming language because you're creating a new framework. You can use existing programming language. As a matter of fact, almost every library that is available in Java can be made available in JavaScript. Okay. So in today's era, the time where people used to write the entire compiler from scratch is gone. Instead, they just use these generic programming languages. You don't have to write the domain specific languages. All right. Good. All right. So Spark R is an R package that provides lightweight front end to use Apache Spark on R. Okay. It provides a distributed data frame implementation that supports operations like selection, filtering, aggregations, etc. It can handle large data set, supports distributed machine learning using MLlib, and we have already talked about data frame. All right, so let me just show you R first. To run R, you can simply say R and press enter. Now we have, this is R interface. Okay, here you can write your R code and start using the usual functions of R. Okay, so for example, let's say if you want to see the demo and you want to see help.start, so it will show you the how to get started with R. Okay, so it says the starting HTTPD server, and you can open this. Let me just check if it is accessible from outside. Okay, so does it open here? Never mind. So it's not really needed here. We don't need this. No, the port is not open. Never mind. So coming back to it, what we're talking. So here you can you can actually yeah, you can actually do your R computing just the way you could do scalar computing or Python computing, right? So on the same lines, Spark came up with R interface by the name of Spark R. Okay, so this is very familiar interface for those who are coming from R background. It's essentially R package. Yeah. Now, basically, this is an R interface with a banner of Spark. So here, Spark's driver has been initialized here inside R and is connected to Spark. Make sense to you? Okay. Mohit's question is, which programming language do you think become more popular in data science? R, Python, Scala? There is no, I'm sorry, I cannot predict that. And on one hand, it feels like R is going to have it is going to have the biggest support, but at the same time, the language is showing its age, because implementing new functions in R is actually little slow. Implementing new functions in R is little slow. So so most of the R's libraries are written in C. Okay. Therefore, new library development is kind of slow on R. So people write in C. Same is the case with Python. Even the most popular libraries of Python, like scikit-learn, scipy, all of those are in C, C++. While in case of Scala, most of the libraries are written in Scala. Therefore, people might move to Scala more. Okay, though as of today, people prefer to use Python Scala for most of the chores. Okay, so a long answer short, I really don't know. Okay, all right. So we have logged into Spark R. So we can create, there is already some data sets in R with the name like faithful and spa and so on. We can use the same data frame, same data frame by using Spark argument in it. So we could say create data frames on this data called faithful. Okay, it's basically volcanic eruption. There's a terminology called faithful in there, and usually if you want to see any data in R, you can always say show faithful. Okay, now, or head faithful. Similarly, here we are creating a data frame. This df is going to be also, please note that this arrow that you see here is equivalent to this. Okay, in my opinion, this should work. Okay, all right. So yeah, so that's the way. And we could always say head df to take a look at first few records in the data set. Okay, so this is the major difference between Spark's data frame and the data frame that came with R. So df is a data frame of Spark, while faithful is the data frame of R. This is R's data frame, and this is the data frame we created. Okay, this one has kind of came out of the box with R. If you just load any R, this data set will be there. Okay, so this data frame called faithful is being converted into data frame of Spark. Now, what is the difference between this and this? What is the actual from the computational perspective? From the computational perspective, which one can handle bigger data? This or this? Okay, looks like I have put everybody to sleep. All right. So there are two data sets. There is a faithful data set, okay, that came out of the box with R. And from faithful, we have created DF. DF is again the same data set called faithful, represented in Spark. Okay, so DF and faithful contains the same data. I'll show you. So if you say head faithful, you see, it's the same data. The DF is created. It's a Spark's data frame, while faithful is under the hood, core R's data frame. Now, question to you is, Out of DF or faithful, which one is, which one can handle bigger data? Naren says DF, RS says DF, Shamit says DF, and okay. No, actually, DF can handle bigger data. Okay, so we talked about R just now, and R sounds like a great environment. But the problem with R was, if you talk to any data scientist, they will tell you the problem was whenever you load a data set, it will load the entire thing into the memory. And when it loads into the memory, basically you cannot compute, you cannot do the computation on a data set which cannot fit into the memory. Okay, so if you meet a data scientist, their main problem would be that they cannot fit the data into their computer, into their machine using R, and therefore they generally need computer scientist or a computer engineer to fix their problems. And when that happens, it becomes a completely messy issue because the data was not fitting into R's memory. Okay, so again, we are going to the same problem where we started MapReduce discussion for counting words. For counting words, when we wrote the hash map, the whole hash map was in memory. And we did entire distributed computing in order to break down the computing to multiple computers, right? And same thing is happening here. When we could not fit the data sets like faithful into the memory, we created a data frame on top of those kind of data, and or we created the data sets, new data set called Spark's data frame from from huge data. Okay, so now the data scientists are very happy with this kind of model because this is exactly they needed they needed they needed the flexibility of R, because R provides you enormous amount of functionalities to slice and dice the data, pick up this column, increase it by 3, then join it with another table, and then group it by this, and then whatever comes out, run through this function and so on. So that kind of computation is very easy with R, and and a lot of machine learning functionalities were available as part of R. So to make use of both the worlds, Spark came up with this Spark R library. Okay, do that make sense to you? All right. Continuing with the same way, the way we created data frame from Spark shell, in the same way, we can also create data frame from JSON. Okay, so you can load data from Spark R just like this. So now people from both the sides who loved uh, uh, Scala as well as who loved both are happy they are able to use this. Okay, so had people. Okay, so let me see if we are able to load JSON. See, we are able to load data. All right, so from R, you can do many operations just the way you did operations from Scala console, like Spark shell. Good. So you can do churning on top of a data frame. Create this data frame is distributed data frame. Please keep in mind, and you can select the data from it. You can pick up a column and so on, and you can filter on it, and you can also summarize the data. As in summarize, as in it would give you the statistics, like how many word count for the how many counts for each one. Summarize gives you the frequency table. Okay, and so on. Right. So this basically gives you the entire Spark inside R. All right. So that's the way we can operate on humongous data using Spark R. All right. And once you are able to load it, the beautiful part is that you can use the R's library, the libraries provided by R on huge data set. Okay, so that was the big advantage of Spark R. So here we are trying to load data from JSON file, the one which we did earlier, similar to what we did from Spark Shell, and then registered is a table. Now, inside the R, you can call SQL. Okay, so that's a very big advantage of having this kind of model, because there could be some scenarios where SQL queries are easier to write than our way of projections. All right, so that's pretty much. So we are not going to get into more detail than this. So our RSS question is, TensorFlow is distributed system like Spark? Not really. TensorFlow is made for different purpose. It is made for mostly the deep learning kind of workflow. Okay, it tries to utilize GPU, but it is not really very distributed. Okay, unlike Spark, because Spark's basic premise is it won't handle huge data. Okay, but good news is that if you have launched say Spark Shell, right, or say PySpark, you can load TensorFlow there, and inside your mapper functions you can call TensorFlow's functions. That way you can run TensorFlow on top of Spark. Do it make sense? Okay. So inside your map function, you can actually call any function. And if, let's say, you are trying to do machine learning and you're trying to do a lot of complex computing, and that computing is largely a black box to you, you can import that library into PySpark or say Spark Shell, and then use that library inside map function if you can break it down. So for example, I'll show you. So let's say there is a library called Stanford NLP. Okay, so what does it do is it converts any line into a sentiment, right? So you can import this library into usual scalar program and call it via map function, and that should be good enough. Okay. All right. A question from Mohsin is, R is used for an example. R is used for the similar purpose like data cleaning, data churning, and then for machine learning. For example, let's say you want to do classification, or we will talk about this in a while. We'll talk about machine learning, then you'll have a clear picture on what kind of functionalities come under machine learning. And R was mainly used for machine learning. The downside of using R on machine learning was that people were not able to use R where the memory was huge. Some people upgraded their machines to 100 gigabytes, but then the same issues occurred, which we talked about earlier, that when you have too much of RAM, then CPU becomes a bottleneck, and so on. Okay, good. So that was our quick discussion on Spark R. So philosophically, everybody is clear about what does Spark R do. Spark R is nothing but R having an extra variable for Spark. Okay. So while creating data frame, you can create using Spark or locally. Okay. Great set of questions. Keep the questions coming, because that's what makes me, think. Otherwise, I get into the usual single direction flow where, okay, so yes. All right. So now let's talk about something called machine learning. Okay. Machine learning, I don't want to get into the mathematical definition, so I would like to keep it very simple. And I would like to make it more fun. Okay, I would love to make it more fun. So instead of reading, instead of trying to mug up this definition, I'll just going to read it out. So programming computers to learn by itself. Okay, that's machine learning. Okay, instead of you trying to figure out each nook and corner, you use an algorithm which has a reward and punishment kind of model, and it learns by itself. Okay, so I'm going to, instead of talking about theory, I'm going to show you something. Okay, I'm going to show you something that you would definitely like. All right, is everybody tuned in? Okay. Why does it always have to present on the other side? All right, play. Okay, so it seems that it's just going to moving the presentation to the next screen. Okay, play, play the show, record the show, customize, share. All right, now it's good. All right, so all right, so can you see my screen? And yeah, all right. So question to all of you is, have you played Mario? All right. So Srini has, Elvin has. Okay. Did anybody win the princess? Okay. Okay. All right. So, and how much time did it take you to learn and play? Okay. Now, how about automating it? Do you believe that, okay, okay. Do you believe that it can be, the learning of a game can be automated, right? The way we have been coding things, the way we have been looking at computing is understanding and writing algorithms, understanding geometry, and trying to do manual way of algorithms, right? We will look at a problem, try to think about how to solve it, and so on, right? But can you believe the way you learned the Mario in the same way? Can a program learn it just by watching it, just by trying to play it? Can it automatically learn any game? Not only Mario, but maybe the tank game, maybe the what do you call, the Pac-Man. So can you believe a computer could learn any game by itself? How many of you believe that it can happen? All right. So that's machine learning without writing a program. without writing a specific program, just by watching the way we learned Mario, the way we learned boxing, the way we learned Pac-Man, in the same way, if the program can also learn to play Mario, that's machine learning. So what I forgot his name. His name is Steve or something. If you search for Learn Fun, you will find it. So what he did was he launched. And by the way, those who are interested in playing Mario, because I love playing Mario, those who are interested, they can launch Mario inside the virtual machine. Okay, you can launch these virtual environments on the PC where you can where you can load any of the cassettes, and then you can play on your computer. Okay, so this guy also did the same thing. He basically uh, modified this emulator instead of and made it such that a program can also play Mario, not only a human. Okay, so program learns to play Mario. It observes the game, presses the key, finds the memory. It basically keeps on observing whether the score is going up or down, and and based on that, it kept on it kept on it kept on trying hard, observing the memory and trying hard. And this program learned Mario. Okay, so what you see is the day zero, when the program is pressing the keys randomly. It's going in no direction and dies of old age without moving forward. So program is just trying all kinds of random possibilities and memorizing what happened in past when we did this. And observing the environment, because environment is stored in the graphical memory. So it's observing that graphical memory and trying to see if it can increase the score. And few weeks later, this is what the program is playing like. Okay. And it doesn't know why it's doing that. It has no clue. We did not teach program about hitting people or jumping on people, or we did not teach anything. We let the program try it out and figure out by itself. Program doesn't even know that there is a gravity. Okay, it figured out that this is how it can increase the score. So few more weeks of keep on trying, the program is now like an expert. You can see that. So it's able to do all kinds of tricks. Now what you're going to see is very amazing. You see that? What was that? It basically, even though the Goomba was falling on it, it actually won it. So it found a bug in the game that the moment Goomba is falling on it, it will start moving slightly downwards and then win it. This is something which nobody knew about. So program found it. Now here another, you'll see it exploiting another bug. What was that? It basically, nobody knows how did he do that. Okay, this is the sign of intelligence. Now the another sign of intelligence, when it is unable to win, it's pausing the game, because that's the only move it is left with in order to win the game. So it's like in the childhood, our cousins or siblings is spoiling the games, is spoiling the carom board or the chess when they could not win it, right? In the same way, when it could not win, it started pausing the game. So this is machine learning. All right. So this is what this sentence mean. Yes. So this is what this sentence mean when I say programming computers to optimize the performance using example data or past experience. Now, probably this sentence means something to you, right? So uh, we programmed computers to optimize a performance, like optimize the play of the game using the past history of playing the game. Okay. Good. Thank you, Mohit. All right. So this is machine learning, and the fact is, what I showed you was a reality. It was done around 1.5 years ago, and same thing has been done now for many things. The reason why the reason why we were able to do so well in playing Mario or or playing Go, right? You remember there was a news about Google playing that they have defeated the world champion in using AlphaGo, right? The way it did was it kept on playing a game called Go. It's a Chinese checker kind of game where you keep on blocking the other party. And there, okay, all right. So, yeah, so so I think you are named after Go, probably. So Go is a very, very complex game. I mean, it has very simple rules. When you have when you have more moves, and when you play on a bigger boards, Go becomes fairly complex. And that Go game is being played in China for like um, for few years. No, I mean for hundreds of years actually. Okay, for hundreds of years. So when and the AlphaGo, which is a machine learning algorithm, which learned Go by playing against each other in the simulation. And it could do so well in real life that it defeated the world champion. And in the initial moves of AlphaGo were absolutely different from what usually or what common sense tells. The common sense of the brilliant people in Go was was defeated by AlphaGo, because when in initial moves, when AlphaGo was playing the moves, the the Chinese player thought that those are totally bogus moves. Those are bogus moves, and in the end, they realized that those were actually the moves which we nobody has played. Just the way Mario, the program could figure out very non-intuitive hacks to the program, to Mario. It could figure out how to dodge Goombas, how to avoid falling into the pit. So in the same way, AlphaGo also figured out those solutions. So most of the programs suffer from the the the, the limitation to which human can think, right? While machine learning, just because it is based on sheer amount of data, and it doesn't hold a bias, it doesn't hold many other uh, mindsets, therefore it is able to come up with the solutions where sometimes human is not able to do great. Okay, although we do very great in terms of visual and in terms of many other problem solving, but there are few areas where machine learning is proving that it can do a better job. Okay, so basically it's a branch of artificial intelligence for design and development of algorithms where computers evolve behavior based on empirical data. Okay, there are three kinds of machine learning: supervised, unsupervised, and semi-supervised. Supervised means we have a clear label data that this is bad, this is good. Can you, given a data, can you tell whether this is good or bad? Okay, that's supervised learning. Unsupervised learning is we are given the data and are told to do things like, can you find anomalies in this data? Or can you classify these a billion emails into 10 buckets? Okay, so that's unsupervised learning. Semi-supervised learning is that you have some of the data as labeled and some of the data as unlabeled, and then you try to infer the information about labels, as well as you try to classify things. Okay, probably this will show you a better example. So first one is a label data. One are triangles, another are circles. And then you have labeled and unlabeled data. Okay, so here the classification is very easy. We just have to draw the line between the two. Okay, and while in this case, the other case is in the semi-supervised learning, we have a difficulty in drawing the line because we can't really separate the unlabeled data. Therefore, we have to figure out other mm, attributes. Okay, so there are many applications of machine learning. All right, these are some of the ways, and they are branches of machine learning that deal with individual examples. For example, there's a branch called computer vision. There's a branch called natural language processing. Okay, and there are branches called speech recognition, speech, vision, and NLP. These are the branches, some of the branches of AI. Okay, so there are many applications. Basically, wherever you have huge data, and wherever we have complex algorithms, then we generally try to take advantage of machine learning. Okay, right. So these are some of the examples. Now here is a very important and interesting chart. So if you have few lines of data, you can actually do predictions by using a whiteboard or pen and paper, right? You can just say that, okay, my last year's salary was this much, and then this year's salary is this much. Next year, this is going to be my salary. Okay, by plotting a graph, you can predict the future, right? That's that's a basic, most simple form of machine learning. It's also sometimes called linear regression or something like that. If you have if you have few kilobytes of data, okay, then you can use tools like R, MATLAB, Octave for doing the machine learning. But if the data starts growing into MBs, now remember, most of these algorithms are far more complex than sorting algorithms. For example, classifying things into buckets is takes far more time and is O(n) cubed kind of algorithm, right? It's fairly complex, and it requires CPU as well as memory, both. So machine learning algorithms are mostly quite complex algorithm. When I say complex, complex means they consume more CPU, and since we are going to consume more CPU, it's always advisable to keep things ready in the memory, and therefore it requires more RAM. So we have, if we have some lower MBs of data, we use R and others. If the data starts going beyond megabytes into gigabytes, then it doesn't make sense to do visualization of gigabytes of data. Why? Because human eye is not sensitive to that kind of data, as well as plotting and presentation will take a lot of time. Therefore, there are two separate tools, one for visualization, other for analysis. And when we start going further to more and more records, right, then it becomes actually impossible to visualize gigabyte of data or beyond. Why? Because one, it's difficult to present that so quickly. Rendering is a big issue. Second, human eye is not too sensitive when data becomes into hundreds of gigabytes. Okay, so out of these, I have used Spark, R, and Mahout, and NumPy, and of course, a whiteboard for doing the predictions. Okay, so now This is what we are talking about. This is what we are talking about. We're talking about this range. This is where big data and machine learning intersect. Okay, and why does machine learning intersect with big data? Anybody? Do you think there is an additional advantage of using machine learning? TensorFlow falls somewhere like this here. Yes, thank you, Mohit. Machine learning is more successful with more data, the way we saw just now, that more number of times program played Mario, the better it got, right? So more the experience, better would be the outcome. Therefore, bigger the data, better is insight. Okay? Bigger the data, better is insight. All right. Earlier, what people used to do is we have huge data, no problem. We'll just do a sample and try to do prediction based on sample. Okay. But because of that sample, a slight variation in the sampling mechanism would lead to huge, hugely defective outcomes. Okay. Therefore, doing processing, doing computing, let's say things like average, mean, are more valuable if we have huge data. Okay, so while we had these older libraries in R and everywhere, Spark came up with MLlib. Spark came up with MLlib. MLlib was to make practical machine learning scalable and easy. It consists of common learning algorithms and utilities, including classification. What is classification? Whether an email is a spam or not a spam. Okay, that is a classification. And the predicting that whether an email should go to spam folder or it should go to another label, that is classification. Okay, regression is my salary last year was this year my salary is this, what will be my next year's salary? That's regression. Clustering is given given all kinds of cars of the world, create a chart, or given all the species of the globe, given all kinds of species of the globe, create a classification chart such that species which are similar to each other, they come into the tree near to each other. That's classification. That's clustering. Clustering is both hierarchical and flat. Flat is where we basically create them into groups, and uh, and the the other one, the hierarchical one, we create kind of a folder structure, keeping similar things into the same folder. So that's clustering. Okay. Collaborative filtering or recommendation. What is collaborative filtering and recommendation? Collaborative filtering means recommendation. Okay, meaning given my history of products that I have liked, what would be what would be the recommendations for us? Okay, what would be the recommendations for us about the movies? So collaborative filtering came into play in 2011 or 10, 11 I think, 2011, by Netflix. Netflix launched a very popular challenge of $1 million, saying that these are the history of movies, who has rated how much. If you can predict it very closer to the real, you will win the $1 million prize. Okay. So next is dimensionality reduction, figuring out which of the parameters are not dependent. And then it provides you these very important primitives. Let's say you want to build your own algorithm. So it gives you these primitives using which you can build or optimize existing algorithm. Okay. Sometimes you want to kind of create pipelines of, by not data pipeline, these are machine learning pipelines. You can use MLlib for that. Okay. So MLlib's structure is that it has four parts. It has algorithms, okay, the common machine learning algorithms. The second is featureization, meaning extracting features, transformation, removing some of the columns and consider them deprecate. And pipelining means tools for constructing, evaluating, and tuning machine learning pipeline. Okay, machine learning pipeline, why do we need it? Because when we are trying to do the predictions, we have the entire flow. There is a initial data, there's a clean data, then there is a feedback coming from the previous learning, and so on. Okay, that's pipelining. Then persistent is saving and loading the models and algorithms. So whatever it learns, whatever things it learns, when it has to be saved, right? That's called persisting the model. The learning thing, whatever it has learned, is called a model, and then it can save that model and reuse it at later point of time. Okay, so a quick back to reality. So in real life, what the way it is happening as of today is, we run an algorithm, we learn we learn from we learn on a single machine. We run a machine learning algorithm on a single machine. As of now, most of the learning mechanisms, most of the learning mechanisms are actually not distributable. Therefore, a common way is specifically the more complex algorithms. They're not able to yet split it to distributed. People are working on it, and most of these algorithms, we make computer learn on a single machine, and then whatever we have learned, we call it model, and then we use distributed computing to apply that model on a humongous data. Let us say we figured out, we have some let's say you have a billion image. You have a billion image and you want to classify whether an image is vulgar or not. So out of billion image, we will manually sit and mark around, say, 1,000 images, saying these are vulgar, these are not. And then we run our machine learning algorithm to train it and tell it that this image means it's a vulgar image. This image means a neat image. Now, once it has done that, once it has learned, okay, it will create something called a model. Now, once we get the model as an engineer, we will load our images into our RDD, apply this model in a map on each of these images, and see if our result is true or false. And then we can filter or do whatever, right? So on one hand, you have deep learning and other stack, which is not generally distributable. But on the other, applying a model or classifying based on the model is something distributable. Okay. So did I make sense to you? All right. So there are quite a few utilities, like linear algebra utilities, how to multiply matrix, how to solve parallel equations. So Mohit's question is, but it defeats the purpose of big data in machine learning. So partially it does. Okay, partially it does, but it is actually quite useful. So every day, for example, the recommendation algorithm, okay, collaborative filtering. Earlier, it was single machine based, but after Mahout came into play, it was possible to convert it into distributable. So every now and then, most of the algorithms keep getting converted into distributed, and that's a cutting edge time for converting more and more algorithms to be distributable, right? the way we converted our sorting problem or frequency counting problem into distributed. Similarly, doing recommendations or writing the program for recommendation is distributable. But as of now, say deep learning, the other neural network based learning, all of those learning algorithms or the strategies, they are still not really distributed. Okay, all right. But there people are working on this. But till then, even if half of the problem of training is still single computer based, but you can apply those models to the general public. Okay, general data sets by distributed way. For example, these models, like Google is training lot of models and providing you, they are selling the models. Okay, they are they are generating models by learning from images, from sounds, from various like YouTube videos. By so they're generating these models which can identify objects in an image. So people are selling these models. You can use these, take buy these models and apply those models on millions of records using Spark or any other. Okay, so it doesn't really defeats the purpose, but just that things are moving fast in that direction. Okay, did I make sense, Mohit? Manu? Okay, so all right. Any questions at this point? Srini, RS, Samit, Ravi, Mohsin, Manu, Kar, George, Alvin? A question from Mohit. Um, Neural network requires more computing power. How is it being managed than currently? Very good question, Mohit. I'll try to answer this. It's a very important question. Okay, all right. So here we go. Now, question is, it's interesting question. Can anybody try an answer? Okay, very good question. So here, the single word answer is GPU. Okay, so yes. So instead of so the other things which we talked earlier was parallel computing, right? So what we do is, in case we are not, in case we are not able to divide a problem such that it can run on many machines, what we do is we run we run the we run the logic parallelly on multiple threads. Okay, now how many threads can you run parallelly depends on how many processors are available, or if a processor is free or not, how many free processors are available. So what people did was like, for example, Nvidia, what they did was they started putting hundreds of cores into a single CPU, and that's called GPU. So hundreds of GPUs, hundreds of processors or microcontrollers are packed into a single computer, and that's called GPU, graphics card. So for example, to run to we were trying TensorFlow, and they suggested that minimum of 8 GB GPU we need. GPU 8 GB is considered really high end, which costs around 1.5 lakh in INR. Okay, okay, close to 20. Okay, how much is it in? All right, so it's around $2,000. Okay, so that's how the current neural network is done. Okay, we generally I have we are planning to put one GPU machine into our CloudX lab. That would happen in couple of weeks, and the idea is to promote people experimenting neural net, even though we are not yet providing a course on that, but we want people to experiment on it. Okay, because buying GPU is costly for people, and since I bought it because we were experimenting with combining videos and video processing, so we have those machines ready, so we'll be putting them in a couple of weeks. Okay, so yes, all right. Now, l- yes, so that's what it does. It keeps each node in one machine, and that's what it does. Okay, now coming to how would you do machine learning with Spark? Okay, so we are going to use MLlib. We're going to launch. We're going to this code is in Python, so it's not a big deal. No, actually, it is in Scala only. Last time we converted. Okay, so let's just start with. I'm going to use a newer version of Spark. Okay, so I'm going to walk you through everything. So we are importing these two classes, regression evaluator and ALS. ALS is the name of algorithm. Okay, so we are importing these two. One is regression evaluator, which is a general class in machine learning, which is used across multiple algorithms. Because to fit to predict, there are many algorithms. Some think that it's a linear path. Some think that it's a it's kind of a curvature, and so on. So here, the what we are trying to do is we are trying to create a class. We are saying that we had a class. Remember, we created a person class and then we loaded the data into it, right? Okay, so those who are wondering what is it that we are trying to do, there is a file we have downloaded movie lens data and put it in the in the lab, okay, and which is available in as part of. So what we are trying to do is we have this data, we have this movies data, right? We have this movies data inside data folder. Okay, can you see my screen? Here we have this, there are three data sets, one containing 100,000 record, other containing 1 million, and other containing 20 million. Okay, now which one are we going to use? We're going to use 1 million one. Okay, so these are 1 million ratings provided by various users, and we have taken it from movie lens. Okay, and here this is information about the movies, each individual movies. Okay, and then we have information about ratings, as in this user called one rated this particular movie as 5. Okay, and this user one rated this movie as 5. Okay, and to know about the user, you have users.dat. You see, user one is a female, and it's the, I think the second one is age, and there are few more categories. To know more about this data set, you can take a look at README. Okay, so README tells you about what is it that's there inside the data. So here it shows you that user ID, gender, age, occupation, and zip code. Okay, so under 18 means 1, and so on. These are the categories, and occupation is represented like this. All right, so So now what we have to do is first we have to load this data. Okay, when you load this data, every line, so let's keep this open. So every line is double colon separated, 2 characters. Yes, everybody's with me. Okay, so the last one is the time when the rating was given by this user. Okay, this is the timestamp. Timestamp is generally counted as milliseconds since 1st January 1970. Okay, this the 1st January 1970 is like the birth time of the computer, specifically the time, and therefore it was safe to count since then. Okay, so all right, so we load the data. Okay, so we are simply saying spark read text file. It will be a data frame. It will be sorry, it will be what do you say? I think it'll be an RDD, and then, or you can simply say spark.text file and you'll get an RDD. Okay, and then you could say raw.map, right? And pass this function. And what does this function do? For each of the record, it's going to split the data based on double colon, right? It's going to split the data based on double colon and then check if the fields are 4, and then it is going to create this object called ratings, field 0, field 1, field 2, converting them into appropriate data types. Okay, once we are done with converting into a kind of structured, we convert it into data frame, because here it will know that which object we are going to use, and then it will convert that into data frame happily. Okay, so let's try it. We are going to define the class first. Okay, so we have defined our class. Okay, those who want to give it a try, I'm pasting for them. All right, and keep in mind that we are using this newer version of Spark. Okay, so where are we? We have defined a class called ratings. Now let's define our function, which is going to split our data into records. Good. In the similar way, now we are going to load this raw data. We could also say sc.text file is the same thing. So we can say raw. It's a data set. We can actually say, let me try using sc.text file. It's the same thing. It'll work fine. Okay, so we have said sc.text file, and then we could say this. All right, now let's take a look at ratings. Ratings dot take or ratings dot head. Does it work that way? Okay, so you can see that this is the first row. All right, so it's showing 20 rows. It has loaded this data. Let's just compare 1 1 1 9 3 5 something, 1 1 1 1 9 3 5 something. Good. Now these columns have been picked up from the name of the class that we had defined. Okay, we defined a class user ID, movie ID, ratings, timestamp. User ID, movie ID, ratings, timestamp. Good. So we have been able to clean our data quickly. Now here's the important part. We are going to use a function called random split. What does random split do? Random split splits a data set into two data sets. Okay? It splits the data set into two data sets. Here we are splitting it into training and test. Training is 80%. Test is going to be 20% of this data. Okay? Why? Because on training, we want to train the computer, and test, we want to compare whether it's actually predicting what is actually happening. Okay, so we are splitting the data based on that. All right, so let's split the data. Okay, it is split, and we can take a look at training dot show. All right, some of the records went to this one, and test dot show, some of the records went to this one. All right, so it has done a random. All right, now once that is done, here we are now, once we have training data, with this training data we can run our model. Okay, user ID, movie ID, and so on. We can run an algorithm on it based on this data to the predictions. Okay, and then test against test data. So here we are saying that because this algorithm runs in multiple iterations, it tries a couple of times. A question from RS, because this show method on a data frame shows you only 20 rows. If you want to see more rows, you can say 1,000 here or 100. You see? All right. Next is here. Next thing which we are trying to do is we are defining our algorithm here. We are saying algorithm set 5 iteration, meaning when it runs, it will run for 5 iteration. And then there are a few more parameters, regression parameters. And then we are telling this algorithm that in our data set, look for user ID in this column, and then item ID in this column, and ratings in this column. Okay, that's what we are telling the algorithm. Now, all right, so now you can see, so what is the ALS? ALS is an algorithm, it's not a data set, it's an algorithm. Okay, so we are saying ALS dot fit. Okay, meaning we generate the model, learn from our training data. This model will take time. You see, it's trying to understand the model. Now let's take a look at model. If it's basically ALS model, you can see that we can save this model and reuse it later, or once we are done with this, we can hand over it to our friend and say that, hey, I had a good CPU, so we generated this model, you can use it for your work whenever you need. Okay, now so we can save it somewhere using the save function. Okay, and reuse it later, tomorrow or day after, or maybe we send it to the Hadoop servers and then execute it there. Okay, so this is where the broadcasting variable will come into play, when we have to send the model to all the machines. Okay, next is predictions. Now we're going to run predictions on this model. So we are saying model dot transform, and we are given this data test. Sorry, here we are we are preparing the predictions, so we can see that when we run predictions, it does some work. So also make a note of this, that the predictions are equally complex as generating the model. Okay. Now you can see that it had generated this user ID. Okay. You can see. All right. So it contains the result. Let's try to understand what does it mean. User ID, movie ID, and rating. This was the original rating. Okay. This was the original time. And the suggested is the last one. Okay. This is the suggested rating. This was the actual rating. This is the suggested rating. It basically ignored this part. It basically ignored this part and gave this rating. Okay. So you can see that actual was 2 and this one is 1.7. So it's not that bad after all. Actual was 4. It gave a rating of 2.8. It's bad here. Okay. While in this case, it's doing good. Okay, the more closer it is to the original, that means it's doing a very good. Here this number represents that this user actually rated this movie 2. Okay, while the program predicted that based on this user and this movie, it predicted that this user might give 2.9 to this movie. So difference between this and this represents how great our algorithm is. I mean, lesser the difference, better the algorithm. Okay, smaller the difference, better is the algorithm. Let's save the prediction somewhere. Okay, we can simply save the predictions. We are saving it in CSV format. We can load the same thing again later on. And since the data is already there, so I'm going to say 14 Jan. All right. And once that's done, that would contain the all product predictions. Did I make sense to you? So now predictions, this file that we have just done, let me order it by date. You can see that it has generated the data on so many machines. Sorry, in so many files, because there are so many partitions to the data. Okay. Okay. So here, these are the predictions. All right. Now we learned from predictions. Sorry, we learned from training and predicted for test. Okay. You can compare it. How can you compare that if these predictions are great or not? We just have to run, say, we just have to run map on these functions on each record, subtracting this from this and squaring it. Okay. And then doing a reduce, summing it up all to produce the standard deviation. That standard deviation will show us the effectiveness of our algorithm. Okay. All right. Are you still with me? Let me copy paste the code, remaining code. So till here I had copy pasted earlier. All right. So up to random split, it was given to you. From random split onwards, let me just give this code to you. Okay. So it basically gave us predictions using machine learning. All right. Now, the assignment for all of you is, first, define a user ID for yourself. Okay, find them after, you can say put 0 for yourself or put some other number. Okay, because in this there is no 0, so you can put 0 for yourself or find the maximum user ID, increase it by 1, give yourself a user ID. Okay, find out the movie IDs that you really like and rate them. Okay, put this in a separate file. Now By combining the training data and your data, by combining these two, okay, by total data and your data, your ratings, generate the recommendations for yourself, the movies that you may want to like, you may want to watch. Okay, so that'll be a true recommendation for you, and based on the movies that you like. Okay, and those recommendations will be free from any kind of vested interest, because if you see Netflix, they might be pushing the movies that they want you to watch. Okay, therefore this recommendation will be the true recommendation of movies for you. All right, so write down this tab in your Google Doc and share with support at No Big Data. All right, is the problem statement clear to all? Okay, so George, the way I'm saying is, first add yourself in there. I mean, basically the data that we were talking about, right? So we are going to generate recommendation based on this file, right? So you generate for your own user ID, you have to generate some data, right? That I like this movie, I like this movie, I like this movie. Now, how to find out about movie IDs? From the another file in this folder called movies. Okay, from this file. Okay, you can download it and take a look. All right, or you can basically load it into your interactive console and do the lookup on it to find out all movies, and then note down their IDs and keep on building the movies that you like. Okay, so you can do entire thing from Spark SQL. Now, did I make sense to you? So once you have generated data for yourself, and you combine this data with the data set we have provided, and then the way these algorithms generally work is they try to find similar users like you based on the movies you like, and then start cross recommending things. The movies that they like extra and you have never watched them, it will give you those other recommendation. Okay, so there are many algorithms and there are many but ALS, it's called uh, least square, and A represents for yeah. This video will be available around 1 hour afterwards. Okay, so those are the movies suggested for you, and yes. So it provides various kinds of data types, MLlib, vector, because these are the data types required by all algorithms, like vector, point, defining a matrix in the form of either breaking down columns into RDD values, or rows into RDD values, or sections of RDD of matrix as RDD records. So these are the ways you can break down a matrix into RDD, and it also defines the pipelines, and it helps you create the pipelines. Basic statistics, just like R, it provides you all kinds of basic statistics like correlations, stratified sampling, hypothesis testing, and random data generation, and kernel density estimation. Those who are interested in understanding these parts, they can take a look at a course called stat statistical inference course on Coursera. Okay, so you will get the idea about what does it mean by hypothesis testing and what does it mean by kernel density estimation. Okay, so I'm not sure. I don't think they have kernel density estimation that, but you will get these very clear. All right. To know more about what kind of library Spark provides, you can take a look at their URL. All right. So this is how you can. We have already talked about it. So we can prepare the summary statistics on any RDT. Okay. And these are the various algorithms provided by MLlib. You can take a look at that. And we have talked about collaborative filtering, where we generated recommendation for this, and it's ALS represented alternating least squares algorithm. Okay, so yes. Now the other algorithm in MLlib, another class of problems is clustering, where we basically, given the data points, we figure out which ones belong to the same cluster. Okay, and there are many algorithms that provide you the clustering. One is called k-means, other is Gaussian, and so on. Okay, there is something called streaming k-means, as in when the new data is coming, you can do the k-means. Okay, here also we are basically trying to demonstrate how to do k-means on huge data. On really huge data, you can do k-means by using Spark. So here there is some data which we will load here, and then we will split this data into two records, and then we define how many partitions do we want from the data, and then we basically train. And once we are done with the cluster, then we basically compute the cost and represent. All right, so this way you can generate k-means. You can take a look at it, you can try running it. K-means is basically splitting data into records. Where does it come into play? Let us say you have emails. You have emails, and you want to classify these emails into, say, 10 buckets. Okay, so you can figure out what are those 10 buckets based on maybe word frequencies. Okay, and so on. So you can use k-means for those kind of problems. All right, and yeah, there are other algorithms. So the MLlib itself is actually worth a course. I mean, it'll basically can span across around the machine learning itself is around 2 months course. Okay, so you can take a look into details. Although we will plan to launch our own machine learning course after finishing what we are doing, and probably after 2 months time we'll be starting our machine learning course. But till then you can take a look at the library of Spark that should give you a decent idea about what does each algorithm do. Okay, now talking about GraphX. So that was machine learning library which could do things like recommendation generation and learn from past, predict the future, categorize things into various buckets, and so on. Right? That was MLlib. MLlib, it provides a bunch of algorithms and data structures to do machine learning. Now, GraphX is a very, very important tool. You remember our PageRank algorithm? How many of you remember it? Okay, good, good. And 5 is a decent number, so I can live with that. Okay, so in PageRank, what we did was we created this graph of who is referring to who, right? And who was referring to who, and keeping the note of how many people are referring to a person, and then the people who are voting to other, they are actually giving the importance, that the rank to the other person. Okay, so that was PageRank algorithm, and there are millions of algorithms, not millions of algorithms, there are thousands of algorithms or more for doing the graph calculation. And graph calculations are hard. Graph calculations are hard, but the general graph problems are categorized into um, around into these. Okay, connected component, triangle counting, label propagation, SVD, and strongly connected component. So these are the algorithms that are difficult to compute. Okay, so whenever we are doing PageRank, if you notice that we needed to run multiple iterations through all the graph. Even if there are 10 elements in a graph, it, it, it suddenly becomes complex. Why? Because you have to iterate through the entire graph. So GraphX basically is a library. It's not a database. It's a library of algorithms for doing various magic, doing the magic on the graph. Okay, so it provides, you can represent the graph in various way, either vertex table this way or this way. And it has, under the hood, it's also using RDD. It converts sometimes this way RDD, sometimes this way RDD. Okay, and it unifies graph computation, because on one hand you can do RDD usually, the breaking the text analysis and breaking it down into records, converting unstructured to structured, and so on. On the other hand, you can take any of these data sets and convert them into graph. Okay, so all of that can happen either from either from a Spark shell or from within your program. Okay, so GraphX is yet available only in Spark, Scala. It is not available inside Python. Okay, so the fundamental operators which GraphX provides are subgraph, join verticals, aggregate messages, and all. And then it has these wonderful libraries. So please note that to use these libraries, you don't need to really learn graph theory. Okay, you can simply use these algorithms out of the box, and trust me, 99% of the cases people really don't need to know what's going on inside an algorithm. Okay, 90, most of the time the problem is related to where is the data, how do I churn it, and can I churn it in distributed way. Okay, that's the main problem. And trust me, I have done the machine learning at least 3-4 times in past on a large scale, and I realized that most of the time we are struggling with cleaning data rather than running algorithms. Okay, so you can run connected components, triangle counting, label propagation. So knowing what each does is important. So please go through these algorithm and you'll get a clear picture that when to use which one. Okay, we talked about PageRank earlier. So here is the PageRank that we are going to calculate using Spark. So we have Justin Bieber following Barack Obama. Barack Obama is following Lady Gaga. Lady Gaga is following back Barack Obama. Okay. While nobody is following Anosis. Okay. Anosis. Martin is following John, and Mache is following John and also Martin. You can see that. Now, it sounds easy when we talked earlier, but in this kind of graph, the complexity very quickly builds. It builds very quickly. Okay, so you can see that here we have, so we have to start from somewhere, and uh, we have to compute this rank. Page rank, or sorry, the rank of any of these people is equal to 0.15 plus 0.85 multiplied by contributions. Okay, multiplied by contributions, meaning to this is only getting contribution of this person, and this person's contribution is the rank of this node divided by 2, because it's basically it's basically giving its rank to two people because it's following two people. Okay, so if you follow somebody, your rank goes down. If somebody follows you, your rank goes up. Okay, that's what is happening. So his rank is getting divided into two because it has voted to two people, and then by virtue of his rank, their rank is getting improved because 0.85 into total contributions. Okay, for example, John is getting rank from him. So the rank of this person divided by 2 plus rank of this person divided by 2. Okay, that becomes that becomes total contribution by this guy and this guy. And then if you sum them up and multiply by 0.85, then plus 0.15 is the rank of John. Okay, is it clear to everybody, or it's just too confusing? All right, so as you can see that this kind of calculation is hard, not because it's very complex and we can't figure it out. It just, we have to do it too many times. Okay, we just have to do it too many times. Also, once we are done with figuring out their rank once, we'll have to do that same again and again, around 4 or 5 times. And that's why the page rank, when as these numbers increase, the complexity, the total number of edges keeps on increasing. Let's say there one more node comes in here, it starts following this, following that, and following this. So the rank of all of these has changed. Okay, and the entire graph need to be recomputed. Therefore, PageRank was a very important algorithm in the history of graphs. Okay, because you could clearly predict who is more important and who is less important. Okay, so here we go. So we have so GraphX has the page rank here. This is what we are going to do. We're going to launch this. We don't have a separate shell for it. We basically would be doing it from here. Okay, so we imported graph library. Then we are saying that this file is what we have that contains the data. We can take a look at it. Okay, the data is in data spark GraphX, data spark GraphX. Okay, you can see these are the users and these are the followers. All right, and to know who is who, let's take a look at the file. All right, let me go back. And so we have one is Barack Obama, two is Lady Gaga, and so one is following two is following one. Okay, let me take a look at the diagram again. So here, Justin Bieber is not being followed by anybody. And who is Justin Bieber? Justin Bieber is 4. Now, 4 is following 1. 4 is following 1, but nobody is following 4. So 2 is following 1. 4 is following 1. 1 is Barack Obama. And Barack Obama is following 2, which is Lady Gaga. And then 6 is following 3, 7 is following 3, 7 is following 6, 6 is following, and so on. So that's it. That is the graph. So we are loading this graph here. Okay, we are loading this graph here. We are saying load this. Okay, and here this is something which as list file function understand very well. So here we go. So we have this file which we have loaded as followers. Then we are loading users by breaking it down into fields. Okay, so this is the way we are breaking it down. Okay, so we are creating users out of it. the second field is a string, and first field is a long. Okay, so these are the users, these are the ranks, and then we say users join rank. Okay, and initially what we are trying to do is, sorry, we have three data sets here: graph, the actual who follows who; ranks, who is uh, the initial rank. So we are giving every page rank uh, to as 0.001 to all the metrics. And then earlier we did one. I don't know why they're doing it 0.0001. Okay. So the next thing we are doing is we are joining users with ranks and username with rank. It's not really required. Once once we are done with the computation, then we would require this. Okay. So all right. All right. Actually, it finished computing the ranks here itself. It finished computing the rank here itself. And then just to give the names to people, we are joining with the names file, and then we are printing it. Okay, so let's take a look. All right, so this is where the iterations are going on. Okay, so you can see that the rank of each one has been computed. Barack Obama is at 1.4, right, highest. And the lowest is Justin Bieber, because nobody is following Justin Bieber. Okay, the second lowest is zero point 0.7, which is Mehdi. And who is this? This person, this person. Okay, because only one person is following it. Nobody is following Justin Bieber, and so on. Okay, I hope there is no Justin Bieber fan and who is mad at me right now. Okay, so all right. So this is the rank that it has computed. Sounds good? Again, first we loaded the graph very simply. In case your data is not in the form of what we have done, we can prepare that using other phases by cleaning up data and so on. And then we just run the graph algorithm. Once we are done with running the graph algorithm, we got the IDs of every node. So we can actually say ranks.show, ranks.print, I think ranks dot either persist or take. Is there a take? Or collect? I think collect will do. Yeah, here it is. So it has actually finished computing the rank here itself. You can see 4 is given 0.15, 6 is given this and that. And once it's done with computing rank, then we are basically joining with the actual data. Instead of IDs, we are replacing with the name. Okay, that's it. So that gives us the complete page rank in a single shot, in a single line. Okay, so you can use your traditional or standard ways of cleaning up data using filter map, flat map, or other ways, using scalar functions or using regular expressions, and then create this graph by passing follower and who is being followed ID, and then we can run the page rank. Right, so that's an example of PageRank. And similarly, you can run other algorithms on data. All right, so that's pretty much with respect to graphics and MLlib. Any questions at this point? No questions? All right. All right. So a question from George. Elvin, I'll let you know. I am yet to finalize it. Most likely tomorrow I'll send you an email. Okay. All right. And question from George. How long will we have access to learning resources after the course is done? So the CloudX Lab will remain active till 14th of April, while the learning resources will remain accessible to you lifelong. Okay. And you can you can you can resubscribe to CloudX Lab once your lab expires. Okay. All right. So now let me just take you through the project. So it's actually very small cost, George. So basically, if you go to CloudX Lab, okay. Yes, Manu. There's a friend who works at LinkedIn, and he was working with me in Mobi. So he had some opening at LinkedIn, and yeah, so he wants some people for his team. Okay, so what we have here is, in case, let's say you want to extend now or enroll now, you can click on this. This is the lab, and yeah. All right. So Ravi, which part do you want me to write on the chat? All right. So it's very small amount, and yeah. Okay, course availability, etc. would be lifelong, and the lab will be up to the 14th of April. In case it expires before that, let us know. We will extend it. Okay, so the project discussion is on 16th session. So here there are, okay, there is one project here. Okay, in the last session, session 18, you have project for weblogs, sentiment analysis, and movie suggestions. Okay, and these are the basic three projects that you have to finish. This Spark project is about the data set that is located here. It's a NASA data set, and it contains the logs of the website. And what we want to do is we want to answer to these questions. So you finish the answer, submit it here. Okay, submit it here, and that should be good. All right, and the okay, so one project is this. You can see these in last session, session 18. Do not worry about these some number of sessions. Some of the sessions we'll be removing because while updating these sessions, I actually ended up adding more sessions here. So okay, so this cleanup will be done very soon. So session number 18 is what contains the three projects: weblog, sentiment analysis, and movie suggestions. Okay, so this one contains further to what we had learned earlier. So earlier what we had done in case of movie suggestions was uh, was based on Hive. You can do the same thing, combine that with the newer technologies, and do it in the real time. That's what is the objective. So you can actually do the same thing. I've written a example here. What you have to do is, as part of this project, you have to compute real-time sentiments of the tweets for any keyword of your choice in real time, and you can do that. Okay. So we are using a natural language processing library. What does it mean? It means the library that tries to understand the language the way human does. Okay, and it basically we use this approach. Okay, so go through this approach and try to answer this. So that's the second project. The third one is the movie suggestions. Okay, the third one is a movie suggestion, where what you have to do is, okay, okay, what we have to do is, you have to compute the movie suggestions for yourself. Please write down the the approach in a Google Doc and share with me. Why Google Doc? So that I can share and comment and also try to modify it for you. Okay, so these are the four big works. First one is movie recommendations for yourself. Second is the sentiment analysis of live tweets. Third is log analysis. This one is simplest, so try. Okay, and this one was here, session number 10. Okay, not sorry, session number 9. So this is the another project here. Okay, another project here, this one, subjective assignment. No, this one. Okay, so finish these exercises and they should help you understand whatever we have learned. Okay. All right. There are a few questions I have to answer. One question is from Ravi. I meant to ask about the course availability, etc. I noticed that the chat session is not coming formatted when downloaded. How will we get it in formatted way? So most of this is available as part of the slides. Okay, all of these slides are available to you in each session. Okay, all of these slides are available to you as part of the sessions. Okay, and you can actually get all of this easily from the slides. Okay, so no worries on that. A question from Elvin. Um, to summarize, do we need to complete all of the session 18 project in order to get a completion certificate? I was led to believe that we only had to complete the no, actually that was only for the Hadoop project. Okay, that was only for the Hadoop part. This one is, and these are very simple and straightforward projects. I'm sure you will be able to do that. Okay, and in case there is a hard requirement from your organization side that you need a course completion certificate, so course attendance certificate, we can send the attendance certification to you. Okay, even when you have not submitted the project. Okay, but it'll be great if you submit the project, because for us it's very important, because whenever there's an opening and you're interested, so we generally take a look at your work, and that's our first way to take a call whether to consider you for a real one. Okay, all right. So Alvin, could you drop an email please, because yeah, support support or reach us at no big data, that'll be great. All right, all right, I'm just I'll try to remember it, but I don't trust my memory too much. Okay. Okay, all right, all right, so yes, so no worries, so we will send you the attendance certificate, Alvin, and in case if you if others also want all right, so in case you have more questions, feel free to let me know. A question from Asin. Business has grown in terms of acquisition. There is always customers common across. There is hardly any link between the data with textual analysis, and data standardization only is 30% data. is curated and reconciled. Yes. Okay. That's true. 30, yeah. Okay. All right. So Marcin, I would love to answer that question. So could you drop me an email because we are running out of time and I would love to answer it in detail actually. Okay. All right. So it was wonderful to have all of you in the class. I really enjoyed your questions and as always, I learned from your great questions. And I look forward for a great interaction in future. Feel free to send me a LinkedIn request and okay, all right, okay, okay, George. So stay connected. If you have questions, drop me an email. And if you want to take up the course again, let us know. And I'm trying to move my course mostly to self-paced recordings. So we are trying hard for that part. And okay, so stay connected. That's the most important part. And yeah, so if we have more consulting work that we can hand it over to you, or you want some problem to be solved, stay connected. All right. So we are not really into the business of into the classic institute way. We are more, we are passionate about data and we are passionate about data engineering, and that's the reason we run these classes. Okay, so all right, so I'm happy, Elvin, that you learned. Okay, you found the class very helpful, and I look forward to connect with you. Okay, I'm happy, RS, that okay, I'm very glad to have you in the session. All right, I love to help you in case you get stuck. You want more input on MLlib. All right. Thank you, Samit. I'm really happy that you enjoyed it. Thank you, Mohit. I'm very happy to know that you found the sessions very helpful. And stay connected. That's the important part. So you can take a look at LinkedIn, Sandeep Giri. So you can send me a request and we can connect over there. Okay, so that's me. All right. So you can search for Sandeep Giri and send me a request. All right. So stay connected. There'll be a lot of opportunities, and luckily for us, most of our students are actually kind of thought leaders in their domains, and that's something very great about these classes. All right. So stay connected. If you feel that you did not like something, feel free to let me know. We can do the course correction. And all right, great. Thank you, Alvin. Thank you, George. Thank you, Manu. Thank you, Mohit. Thank you, Ravi. Thank you, Shamit. Thank you, RS. Thank you, Srini. I totally enjoyed this session. I look forward to have more interaction with you. All right. And in today's world, there's no point of saying goodbye because we would stay connected. All right. Yes. Great. And all right. Bye bye. And okay. Yes. See you later.